So working to find correlation within Geogebra, we'll go to our website Geogebra, and where we want to go is spreadsheet. Since we want to input data, spreadsheet is where we want to go. So you click on spreadsheet and it will open up a page like this. And then what you want to do is in column A, you input the independent variable. So column A should always be your X coordinates. And then column B is your dependent variable, so all of your Y coordinates. So we input all of that in. Now, something that you're going to want to do when working in this section and with the rest of linear regression, sometimes Geogebra doesn't show enough decimal places, so always be sure when you're working with linear regression, or it's even good for anything you do in Geogebra, since they often round to 2 decimal places, you'll want to adjust your settings. If you go to settings, so hitting those 3 bars, scroll down to settings, it has these different things you can adjust, and something we want to do is adjust the rounding. So go to rounding, and where it says 2 decimal places, at least bump it up to 4. I might even go to 5. Sometimes it's nice to see a little bit more. More the better. Don't worry about significant figures, but as long as you have enough decimal places. So I'm going to bump it up to 5 decimal places, and this is just going to help with future calculations, where if we only have 2 decimal places, it just rounds way too much. So after making that adjustment, let's move on. So we have our data in column A and in B, and what we want to do is highlight the data. So we highlight our data, and what we want to do is go where we used to go for one variable analysis. So you want to click on the histogram symbol up here in the left, and where before we always went to one variable analysis to get our mean, our standard deviation, and histograms, that was great for that data, but remember now we have 2 variables. Since we have 2 columns of data, we want to go to 2 variable regression analysis. So look for the scatter plot. That's what we want to look for. And first thing you're going to see is your scatter plot. And this is how we're going to just check our conditions for moving forward with finding R and eventually finding this equation of the line. Make the scatter plot within technology. Even though we did it by hand, you're going to need technology anyway, so just do it in there. And for checking our conditions, for right now, all we want to see is that we have nice linear data. And again, it just needs to be roughly linear. We want to avoid any obvious curving trend of all of the data, and this doesn't have that. So this looks fairly linear. So we get our scatter plot out. Then where we want to go is our summation x symbol right here, where it says show statistics. This is going to give us all of the information that we need for our correlation. So clicking on that button, we get all of this information out. They give us the mean of x, the mean of y. So basically this 80.13, that's the mean of column A. Mean of column B is at 16.67. They give you the average of each column. They give you the standard deviation for each column. So it kind of does the analysis for single variables here as well. Where we really want to go is here to R. R equals 0.8135. That right there is our correlation. And what you'll see is underneath it is our population correlation. Never use that number there. Even if you have population data input, how it's calculating things correctly is with that value of R. So R is our 0.8135. So that helps us with our example here. So checking our conditions, we check those conditions because it looks roughly linear. We'll talk about more conditions in future videos. And then what is the correlation? R equals 0.8135. Now, analyzing that correlation, we're going to be describing the association between the 2 variables. And having this value for R tells us where to go on this number line. So with R equals 0.8135, that's telling us that we're landing right here. And what that means is we get 2 pieces of information. There's a strong association and it's a positive association. So describing it, The association between temperature and chirps per second is strong and positive. So this gives us the idea that they're strongly related to each other. Again, that doesn't confirm a cause and effect relationship. There's still possibilities of a lurking variable, but we see a strong association between the two and an increasing association. Positive gives us an idea of the direction. And then, like I said, do these results confirm that increased temperature leads to a higher number? No. That wording is too definite. We don't know cause and effect. All we see is an association. Overall, there's a trend that as temperature increases, chirps increase as well, but there could be some other factors that are actually causing that relationship.